Okay, so in these kind of questions, what we need to look for, and what's really important, is we're checking what the actual question's asking. So this one's asking here that a little man computer, a similar language program is stored in memory as shown on the screen. In this variant of LMC, the symbols ampersand and hashtag are used to denote different modes of addressing. How could we use pipelining? So what we'd probably do is, obviously the first instruction would get fetched as normal. Whilst the LDA is being decoded, we would then go and fetch add. Whilst LDA is being executed, add's going to be decoded and out's going to be fetched. So instruction 2, that's going to be fetched. LDA is going to be, add is going to be decoded, whilst LDA is being executed. Now what you need to be careful of in these kind of questions is that there's no branch commands. In this program, there isn't any branch commands, so it's absolutely fine, but we can use pipelining as well. We can't really use it if we've got a branch command, because you might be waiting for the accumulator to come up with some sort of value before you can go and do that branch. So if you're pipelining, that won't work. So what we would say is overlap instructions in the CPU, e.g. you'd say out would be fetched, the add would be decoded, whilst the LDA is being executed. Now the whole point of pipelining is that we're overlapping these processes, we're overlapping these parts of the CPU to ensure that every single part of the CPU is being used at the same time. So we're using efficient use of the CPU. Now, our next question, we've got in this program, we've got some branches in here. You're supposed to take in two numbers and output the higher, identify an instruction in LMC that would cause a PC to change in a different way. So that's looking at how can you change how it's processed. So instead of being incremented by 1 each cycle, how do you change the program counter? So that's going to be any branch command. So that could be BRA, BRP, or BRZ. Only one of those, but any of them. Then state which register the contents of the program counter would be copied to in order for the processor to access the next instruction. Well, that's the location. So the register that stores the location is the memory address register. So we'll just put in MAR there. Then we've got a nice easy question here. We've got LMC again. What does sub do? So it subtracts. So we can just put subtracts. And state the name of the register the result is stored. So any mathematical or logical result is stored in the accumulator. So we can just put accumulator. And there's our answers there. And that's it for this set of questions. A few bits on a bit of LMC. So now I've got another LMC question where if a value on a copy machine is a 1, it's going to accept it. If it's 0, it's not. Okay, so we can see here, if we look through, we were inputting our value, we're going to store that in entry. We're going to look at the max, which is 5, and subtract that from what we type in. So clearly we can type in a load of numbers. If they're valid, it's going to accept it, because we can see here we've got BRP accept, which is going to take us to wherever accept is, which is going to load green light and give us a 1. And then if not, it's going to jump to these instructions here. So how a branch works is it's going to check that if the accumulator is positive, it's going to go to this line here. If it's not, it's just going to carry on and then end. So what we do, if we input a 1, so if the entry is 1, we're going to store that in entry, so that'll be 1 there. It's then going to subtract whatever entry is. So we're going to load the max, so we're going to get 5. Then we're going to subtract from entry, so take away 1, that's going to equal 4. That's positive, so that's going to accept that. it's going to go to the green light, it's going to load the green light, and it's going to print an end. So we already know that the first one is going to be a green light. Now, if we think about, we get to 5 take away 5 equals 0. It's branch while positive or 0. So it means that all of these are going to be valid. All the rest of them are not going to be positive, because 5 take away 6 is going to be -1. So you can just tick those in there. And that is pretty much the answer to this question. That's why it's so few marks, because it is just a bit of simple maths. If you can work out how the first one works, you can pretty much guess the rest of them. But you could obviously do 5 take away 2, 5 take away 3, and so on to get the correct answer. So that's 2 marks there, just for simply tracing the program and figuring out where those branches go.